Hello viewers of AraaTech. As always, bringing another topic which is all about a software tool, Open Interpreter and artificial intelligence. Let's talk about that. Open Interpreter is a software tool designed to enable users to execute computer code using natural language instructions. It serves as a bridge between human language and programming languages, allowing individuals to communicate their computational needs in plain language rather than writing code directly. The natural language interface provided by Open Interpreter is one of its most significant features. Natural language interface. Ease of use. Open Interpreter's natural language interface simplifies the process of interacting with computers by allowing users to input commands and instructions in everyday language. This eliminates the need for users to learn specific programming, syntax, or constructs, making the interaction more intuitive and accessible. Human-computer interaction. By understanding and processing natural language input, Open Interpreter bridges the gap between human language and machine code. This enhances the communication between users and computers, enabling more natural and conversational interactions. Reduced cognitive load. Traditional programming languages often require users to memorize syntax rules and programming constructs, which can be daunting for beginners. With Open Interpreter's natural language interface, users can focus on expressing their intentions in familiar language without being burdened by syntax complexities, reducing cognitive load and barriers to entry. Increased productivity. The intuitive nature of the natural language interface can lead to increased productivity as users can quickly articulate their requirements without getting bogged down by technical details. This streamlines the development process and allows users to focus on problem solving and creative tasks rather than syntax correction. Accessibility. The natural language interface makes computing accessible to a broader audience, including individuals who may not have background in programming or technical fields. This inclusivity fosters diversity and empowers users from various backgrounds to harness computational capabilities for their needs. Versatility. Open Interpreter's natural language interface is versatile and adaptable to different contexts and domains. Users can input a wide range of commands and instructions, from simple calculations to complex data analysis tasks, using language that suits their preferences and requirements. Feedback mechanisms. Open Interpreter may provide feedback to users based on their natural language input, helping them refine their instructions and debug potential errors. This feedback loop enhances the user experience and facilitates iterative improvement in communication with the system. Overall, the natural language interface of Open Interpreter revolutionizes the way users interact with computers, making programming more accessible, intuitive, and inclusive. By enabling users to express their computational needs in everyday language, Open Interpreter empowers individuals to leverage the power of computing without being hindered by technical barriers. Code translation is a crucial functionality of Open Interpreter that facilitates the execution of natural language commands by converting them into executable code in programming languages like Python, JavaScript, or others supported by the tool. Code translation process. Parsing natural language input. When a user inputs a command or instruction in natural language, Open Interpreter first parses the input to understand its semantic meaning. This involves breaking down the input text into its constituent parts such as nouns, verbs, adjectives, and adverbs. Semantic analysis. After parsing the input, openinterpreter performs semantic analysis to interpret the meaning of the natural language text. This step involves identifying the intent behind the user's command and extracting relevant parameters or context necessary for code generation. Based on the parsed and analyzed natural language input, openinterpreter generates equivalent code statements in a programming language supported by the tool. This code generation process involves mapping the user's instructions to corresponding programming constructs, functions, or algorithms. Syntax transformation. Once the code statements are generated, openinterpreter ensures that the syntax conforms to the rules of the target programming language. This may involve formatting the code according to language-specific conventions, handling indentation, and adding necessary punctuation or delimiters. Error handling. During the code translation process, openinterpreter may detect errors or ambiguities in the natural language input. It provides feedback to the user such as error messages or suggestions for clarification to aid in refining the command and resolving any issues. Optimization optional. Depending on the implementation, openinterpreter may perform optimizations on the generated code to improve its efficiency or readability. This could include simplifying expressions, removing redundant statements, or applying best practices specific to the target programming language. Execution. Once the code translation is complete and validated, openinterpreter executes the generated code within the designated execution environment. This could be a local runtime environment on the user's machine or a remote server depending on the deployment configuration. Key considerations. Language support. openinterpreter supports multiple programming languages, allowing users to choose the language that best suits their requirements or preferences. Accuracy and robustness. The effectiveness of code translation depends on the accuracy and robustness of openinterpreter's natural language processing algorithms. Continuous refinement and improvement of these algorithms are essential for enhancing the tool's performance. Extensibility. Openinterpreter may offer mechanisms for extending its language support or customizing code generation rules to accommodate specific use cases or domains. Feedback loop. A feedback loop between users and openinterpreter is crucial for iteratively improving the translation process. Users' input and feedback help enhance the tool's understanding of natural language commands and its ability to generate accurate code. Overall, code translation is a fundamental capability of openinterpreter that bridges the gap between human language and machine code, enabling users to express their computational needs in natural language and execute them effectively using programming languages. The execution environment is a crucial component of openinterpreter, providing the infrastructure for interpreting and executing the code generated from natural language commands. Execution environment in openinterpreter. Designated environment. Openinterpreter operates within a designated execution environment which serves as the platform for interpreting and executing the code generated from natural language commands. This environment may vary depending on the deployment and use case. Command line interface (CLI). In some implementations, openinterpreter may provide a command line interface (CLI) for users to interact with the tool. Users can input natural language commands via the command line and the generated code is executed within the same environment. Web-based application. OpenInterpreter may also be deployed as a web-based application accessible through a web browser. Users can input commands via a graphical user interface (GUI) provided by the web application, and the generated code is executed on the server or client side depending on the architecture. Integrated Development Environment (IDE). Some versions of OpenInterpreter may integrate with popular integrated development environments (IDEs) used by programmers. This integration allows users to input natural language commands directly within the IDE, leveraging the tool's capabilities seamlessly alongside traditional coding workflows. Local versus remote execution. Depending on the deployment configuration and user preferences, OpenInterpreter may support both local and remote execution of generated code. Local execution occurs on the user's machine, while remote execution involves running the code on a remote server or cloud infrastructure. Security and access control. The execution environment in OpenInterpreter may incorporate security measures to ensure the integrity and confidentiality of user data and code. This includes access control mechanisms, encryption of communication channels, and protection against unauthorized access or tampering. Feedback and output. During code execution, OpenInterpreter provides feedback to users, including any output errors or warnings generated by the executed code. This feedback mechanism helps users understand the results of their commands and diagnose any issues that may arise. Key considerations. Scalability. The execution environment should be scalable to accommodate varying workloads and user demands, particularly in scenarios with high concurrency or resource-intensive computations. Compatibility. OpenInterpreter should be compatible with different operating systems, programming languages, and development environments to cater to a diverse user base and use cases. Performance. The performance of the execution environment, including code interpretation and execution speed, is critical for providing a seamless user experience and maximizing productivity. Integration. Seamless integration with existing software tools, frameworks, and libraries is essential for enhancing the utility and versatility of OpenInterpreter in real-world scenarios. Overall, the execution environment in OpenInterpreter plays a vital role in enabling users to leverage the power of natural language programming effectively by providing a flexible, secure, and accessible platform for code interpretation and execution. OpenInterpreter empowers users to interact with computers in a more intuitive and efficient manner. Supported languages and libraries. OpenInterpreter may support various programming languages and libraries. Depending on its design and capabilities, users can leverage these languages and libraries to perform a wide range of tasks, from simple calculations to complex data analysis and application development. The supported languages and libraries in OpenInterpreter significantly contribute to its versatility and utility for users across different domains and use cases. Supported languages and libraries. Programming languages. OpenInterpreter typically supports a range of programming languages commonly used in software development. This may include languages such as Python, JavaScript, RUBY, Java, C++, Swift, Go, R, PHP, and others, depending on the tool's design and capabilities. Libraries and frameworks. In addition to supporting core programming languages, OpenInterpreter may also integrate with various libraries and frameworks commonly used for specific tasks or domains. These libraries extend the functionality of the supported languages and enable users to perform advanced computations, access external services, or interact with data sources. Examples of libraries and frameworks may include NumPy and Pandas for data manipulation and analysis in Python, TensorFlow and PyTorch for machine learning and deep learning tasks, Beautiful Soup and Scarpy for web scraping, and data extraction. Flask and Django for web development in Python. React and Vue.js for front-end development in JavaScript. SQL, Chemi, and Django ORM for database interaction in Python. Matplotlib and Seaborn for data visualization in Python. Spring and Hibernate for enterprise Java development. Laravel and Symfony for web development in PHP. Domain-specific libraries. Depending on the target audience and use cases, OpenInterpreter may support domain-specific libraries tailored to particular industries or applications. For example, BioPython for bioinformatics and computational biological tasks. NLTK, Natural Language Toolkit, for natural language processing tasks. OpenCV for computer vision and image processing. NetworkX for network analysis and graph algorithms. TensorFlow.js for machine learning in JavaScript environments. Unity ML agents for reinforcement learning in game development. Key considerations. Language ecosystem integration. OpenInterpreter should seamlessly integrate with the ecosystems of supported programming languages, allowing users to leverage existing tools, documentation, and community resources. Library availability and updates. Regular updates and additions to the supported libraries and frameworks ensure that users have access to the latest features and improvements, enhancing the tool's relevance and effectiveness. Community support. A vibrant community around OpenInterpreter and its supported language and libraries fosters collaboration, knowledge sharing, and troubleshooting assistance for users. Customization and extension. OpenInterpreter may provide mechanisms for users to extend or customize the supported languages and libraries to meet specific requirements or integrate with proprietary systems. By supporting a diverse range of programming languages and libraries, OpenInterpreter empowers users to tackle a wide spectrum of tasks, from simple scripting to complex data analysis and application development, using natural language commands and instructions. This broadens the tool's applicability and makes it accessible to users with varying backgrounds and expertise levels. Error handling and feedback mechanisms are essential components of OpenInterpreter, ensuring a smooth and efficient user experience by assisting users in identifying and resolving issues that may arise during code translation and execution. Error handling and feedback in OpenInterpreter. Syntax errors. OpenInterpreter detects syntax errors in the natural language input or the generated code and provides feedback to the user. This includes highlighting specific parts of the input text or code that contain errors and suggesting corrections or clarifications. Semantic errors. In addition to syntax errors, OpenInterpreter may also identify semantic errors in the natural language input, such as ambiguous commands or conflicting instructions. The tool offers feedback to help users refine their instructions and clarify their intentions. Error messages. When errors occur during code translation or execution, OpenInterpreter generates informative error messages that describe the nature of the problem and suggest possible solutions. These error messages help users diagnose and troubleshoot issue effectively. Debugging assistance. OpenInterpreter provides debugging assistance to users by offering insights into the translation process and highlighting potential sources of errors. This may include step-by-step execution of the code, variable inspection, and visualization of program flow. Interactive feedback loop. OpenInterpreter fosters an interactive feedback loop between users and the tool, allowing users to iteratively refine their commands and instructions based on the feedback provided. This iterative process improves the accuracy and effectiveness of code translation over time. Documentation and help resources. OpenInterpreter may offer built-in documentation and help resources to assist users in understanding error messages, troubleshooting common issues, and learning best practices for using the tool effectively. Key considerations: clear and informative messages. Error messages and feedback provided by OpenInterpreter should be clear, concise, and informative, helping users understand the nature of the problem and how to resolve it. Contextual feedback. OpenInterpreter takes it into account the context of the user's instructions and provides feedback that is relevant to the specific task or command being executed. Support for multiple languages. OpenInterpreter offers error handling and feedback in multiple languages to cater to users from diverse linguistic backgrounds. Continuous improvement. OpenInterpreter continuously improves its error handling and feedback mechanisms through user feedback, testing, and iteration, ensuring a seamless user experience and high quality output. Integration with development environments. OpenInterpreter may integrate with popular integrated development environments, IDEs, or text editors, providing real-time feedback and error highlighting as users write code. By providing robust error handling and feedback mechanisms, OpenInterpreter empowers users to navigate the complexities of natural language programming with confidence, enabling them to debug and refine their instructions effectively and efficiently. This enhances the overall usability and reliability of the tool, making it a valuable asset for users across various domains and skill levels. Customization and extensibility features. Custom commands. OpenInterpreter may allow users to define custom commands or aliases for frequently used operations. User can create shortcuts or abstractions for complex tasks, simplifying the interaction with the tool and improving productivity. Integration with external APIs and services. OpenInterpreter may support integration with external application programming interfaces, APIs, and web services. User can leverage these integrations to access data, perform actions, or interact with third-party services directly from their natural language commands. Plugin architecture. Some implementations of OpenInterpreter may support a plugin architecture that enables users to extend the tool's functionality through custom plugins or modules. Users can develop and deploy plugins to add new features, enhance existing functionality, or integrate with external systems. Scripting and automation. OpenInterpreter may provide scripting capabilities that allow users to automate repetitive tasks or create custom workflows using natural language commands. Users can script sequences of actions, perform batch processing, or orchestrate complex workflows without writing code directly. Template generation. OpenInterpreter may offer template generation features that allow users to create reusable templates for common tasks or projects. Users can customize these templates to suit their specific requirements and use them as starting points for new projects or tasks. User preferences and settings. OpenInterpreter may provide options for users to customize their preferences and settings such as language preferences, default behavior, or output formatting. This allows users to personalize their experience with the tool and adapt it to their workflow. Key considerations. API documentation and support. OpenInterpreter should provide comprehensive documentation and support for with external APIs and services, helping users understand the capabilities and limitations of these integrations. Plugin development resources. For users interested in developing custom plugin or modules, OpenInterpreter should offer resources such as development guides, APIs, and sample code to facilitate plugin development and deployment. Community contributions. OpenInterpreter may encourage community contributions and collaboration by providing platforms for sharing and distributing custom commands, plugins, and scripts developed by users. Security considerations. OpenInterpreter should incorporate security measures to ensure the integrity and safety of custom commands, plugins, and integrations, mitigating potential risks such as unauthorized access or data breaches. Compatibility and interoperability. Customization and extensibility features in OpenInterpreter should be designed to ensure compatibility and interoperability with existing systems, tools, and standards, minimizing friction and integration challenges for users by offering customization and extensibility options. OpenInterpreter empowers users to adapt the tool to their unique requirements, integrate it with external resources and services, and enhance its functionality to suit a wide range of use cases and domains. This flexibility fosters innovation, collaboration, and productivity, making OpenInterpreter a valuable asset for users seeking to leverage natural language programming in their workflows. OpenInterpreter's versatility makes it applicable across various domains and scenarios, catering to a diverse range of users with different backgrounds and objectives. Education and learning. Beginners programming education. OpenInterpreter provides a user-friendly interface for beginners to learn programming concepts without the complexity of traditional syntax. Students can experiment with code and understand programming principles through natural language instructions. Teaching computational thinking. OpenInterpreter can be used to teach computational thinking and problem-solving skills to learners of all ages. By translating natural language commands into code, it helps learners understand the logic and structure of algorithms. Software development and prototyping. Rapid prototyping. Professionals can use OpenInterpreter to quickly prototype ideas and concepts without delving into detailed coding. It enables rapid experimentation and iteration, facilitating the development of proof of concepts and prototypes. Cross-disciplinary collaboration. OpenInterpreter fosters collaboration between technical and non-technical team members by providing a common platform for expressing and implementing ideas. It enables effective communication and collaboration across diverse skill sets. Research and computational linguistics. Exploring computational linguistics, researchers in computational linguistics and natural language processing (NLP) can leverage OpenInterpreter to experiment with language models, linguistic algorithms, and natural language processing techniques. It provides a flexible environment for exploring and testing linguistic theories. Prototype development. OpenInterpreter can be used to develop prototypes for language-based applications such as chatbots, virtual assistants, and text analysis tools. Researchers can quickly implement and evaluate different approaches using natural language instructions. Task automation and workflow optimization. Automating repetitive tasks. Non-technical users can automate repetitive tasks on their computers using OpenInterpreter. They can perform actions such as file management, data processing, web scraping, and social media management using natural language commands without writing code. Workflow optimization. OpenInterpreter helps streamline workflows and improve efficiency by automating routine tasks and simplifying complex processes. User can create custom scripts and workflows to optimize their daily routine and enhance productivity. Accessibility and inclusivity, empowering non-technical users. OpenInterpreter empowers non-technical users to leverage the power of computing without the need for programming expertise. It makes computational tools and techniques accessible to a wider audience, fostering inclusivity and democratizing technology. Assistive technology. OpenInterpreter can be used to develop assistive technology solutions for individuals with disabilities by providing a natural language interface. It enables users with diverse needs to interact with computers and access digital resources more effectively. Data analysis and visualization, data exploration and analysis. OpenInterpreter enables users to perform data analysis and visualization tasks using natural language commands. They can clean, manipulate, analyze, and visualize data without the need for specialized programming skills, facilitating data-driven decision-making. Interactive data exploration. Researchers, analysts, and decision-makers can interactively explore datasets and generate insights using OpenInterpreter. They can ask questions, experiment with different analyses, and visualize results in real time using natural language instructions. Overall, OpenInterpreter's broad applicability makes it a valuable tool for individuals and organizations across various domains, empowering users to harness the power of natural language programming for education, research, productivity, and innovation. Its intuitive interface and flexible capabilities cater to the diverse needs and objectives of users, making it a versatile asset in the digital age. Ambiguity in natural language instructions. Understanding user intent. OpenInterpreter may struggle to accurately interpret the user's intent from natural language instructions, especially in cases where instructions are ambiguous or context dependent. This can lead to misinterpretation and incorrect execution of commands. Handling ambiguous commands. Resolving ambiguity in natural language commands poses a significant challenge for OpenInterpreter. Users may unintentionally provide instructions that can be interpreted in multiple ways, leading to unpredictable behavior or errors in code translation. Limitations in understanding context and semantics. Context sensitivity. OpenInterpreter may have difficulty understanding the context in which natural language commands are issued, leading to incorrect assumptions or interpretations. Understanding context is crucial for accurately translating commands into executable code. Semantics understanding. While OpenInterpreter may excel at basic language understanding, it may struggle with more complex linguistic concepts and semantics. Understanding nuances, idiomatic expressions, and domain-specific terminology can be challenging for the tool. Security risks associated with executing arbitrary code. Code execution risks. OpenInterpreter's ability to execute arbitrary code poses inherent security risk, especially if the tool is deployed in environments where malicious actors may attempt to exploit vulnerabilities. Executing untrusted or poorly validated code can lead to security breaches or system compromises. Data privacy concerns. Users must exercise caution when executing code through OpenInterpreter, as it may have access to sensitive data or resources on the user's system. Malicious commands could potentially lead to data leaks on unauthorized access to confidential information. Scalability and performance. Scalability challenges. As the complexity and volume of natural language commands increase, OpenInterpreter may face scalability challenges in terms of processing speed, memory utilization, and system resources. handling a large number of concurrent users or complex computational tasks may strain the tool's capabilities. Performance overhead. Translating natural language commands into executable code incurs performance overhead compared to direct execution of pre-written code. This overhead may be acceptable for small-scale tasks, but could become prohibitive for large-scale or time-critical applications. Learning curve and user adoption. Learning curve. Users may encounter a learning curve when transitioning from traditional programming paradigms to natural language programming with openinterpreter. Understanding how to effectively communicate instructions in natural language and interpret feedback from the tool requires practice and familiarity. User adoption challenges. Convincing users to adopt openinterpreter as their primary programming tools may be challenging, especially in environments where traditional programming languages are deeply entrenched. Overcoming resistance to change that demonstrating the benefits of natural language programming is essential for widespread adoption. Maintenance and support. Maintenance complexity. Maintaining and updating openinterpreter to address bugs and new features and improve performance can be complex, especially given the inherent challenges in natural language processing and code translation. User support requirements. Providing adequate user support for openinterpreter, including documentation, tutorials, and troubleshooting assistance, is essential for ensuring a positive user experience. Addressing user inquiries and issues promptly can enhance user satisfaction and adoption. Overall, while openinterpreter offers exciting possibilities for simplifying interaction with computers through natural language programming, it is not without its challenges and limitations. Addressing these challenges requires ongoing research, innovation, and collaboration among developers, researchers, and users to unlock the full potential of natural language programming in real-world applications. Overall, openinterpreter represents an innovative approach to human-computer interaction, enabling more accessible and intuitive ways to harnessing computational power. Its development and adoption continue to evolve, driven by advancements in natural language processing, artificial intelligence, and programming technologies. The benefits of openinterpreter are significant and can have a transformative impact on how individuals interact with computers. Benefits of openinterpreter: lower barrier to entry. People with limited coding experience can automate tasks or leverage computer power with natural language instructions, eliminating the need to learn complex programming languages. Increased efficiency. Automating repetitive tasks with code can save time and effort, enhancing productivity in various domains. Improved accessibility opens up the powers of computers to a wider audience who might not have been comfortable with traditional coding, fostering inclusivity and empowerment. Flexibility works with multiple programming languages, allowing for a variety of tasks and catering to diverse user preferences and requirements. Local execution runs on your own machine, giving you control over your data and avoiding limitations of cloud-based solutions, ensuring privacy and security. Subsets upgraded with openinterpreter. Data analysis. Instruct openinterpreter to clean, analyze, and visualize data using natural language commands, enabling users to make sense of data without strong programming skills. Automation. Automate repetitive tasks on your computer such as file management, web scraping, or social media management, streamlining workflows and reducing manual efforts. Content creation. Generate basic scripts, code snippets, or control software for creating tasks, like photo editing, enhancing creativity and efficiency in content production. Pros and cons in practical life: faster prototyping, quick idea validation. OpenInterpreter enables users to quickly translate their ideas and concepts into executable code using natural language. This rapid prototyping process allows for the swift validation of ideas without the need for writing detailed code or dealing with syntax intricacies. Time savings. Compared to traditional development methodologies that involve writing code line by line, using OpenInterpreter can save significant time during the prototyping phase. This time-saving aspect is particularly beneficial for iterative development cycles and time-constrained projects. Iterative experimentation. With OpenInterpreter, users can iteratively experiment with different approaches and solutions by expressing them in natural language commands. This flexibility fosters creativity and innovation by encouraging exploration and iteration without the overhead of traditional coding practices. Democratization of coding. Accessibility for non-programmers. OpenInterpreter breaks down barriers to entry for individuals who may not have a background in programming by offering a natural language interface. It empowers a wider audience, including students, professionals from non-technical fields, and hobbyists, to engage with computational capabilities. Inclusive innovation. By democratizing access to programming, OpenInterpreter promotes inclusivity and diversity in the tech industry. It allows individuals from diverse backgrounds and skill levels to participate in the creation and innovation of software solutions, leading to a richer and more inclusive technology ecosystem. Cross-disciplinary collaboration. OpenInterpreter facilitates collaboration between technical and non-technical stakeholders by providing a common platform for expressing and implementing ideas. This cross-disciplinary collaboration fosters creativity, problem-solving, and innovation by leveraging the collective expertise of diverse teams. Error reduction. Automated translation. OpenInterpreter's ability to automatically translate natural language commands into code helps reduce human errors associated with manual coding. By eliminating the need for users to write code directly, it minimizes syntax errors, typos, and logical mistakes that may occur during manual coding. Improved accuracy. The automated translation process of OpenInterpreter ensures consistency and accuracy in code generation, leading to more reliable task execution. By adhering to predefined language rules and best practices, it reduces the likelihood of errors and inconsistency in the generated code. Enhance reliability. With OpenInterpreter, users can rely on the tool's natural language processing capabilities to accurately interpret their instructions and translate them into executable code. This enhanced reliability streamlines the development process and reduces the risk of errors and failures in task execution. Overall, the pros of faster prototyping, democratization of coding, and error reduction demonstrate the significant advantages of using OpenInterpreter in various contexts, from software development to education and beyond. By leveraging natural language programming, OpenInterpreter empowers users to innovate, collaborate, and achieve their goals more efficiently and effectively. Those are valid considerations to keep in mind when assessing the limitations of OpenInterpreter. Learning curve. Initial investment required. While OpenInterpreter simplifies the programming process by allowing users to express commands in natural language, there is still a learning curve associated with understanding how to effectively communicate desired actions. Users must become familiar with the tool's syntax, vocabulary, and capabilities, which may require some initial investment in learning and adaptation. Adjustment period. Users transitioning from traditional coding practices to natural language programming may experience an adjustment period as they learn to express their intentions in a manner that openinterpreter can interpret accurately. This adjustment period may vary depending on the user's background, experience, and familiarity with natural language processing concepts. Complexity limitations. Suitability for simple tasks. While openinterpreter excels at simplifying the execution of common and straightforward tasks, it may not be well suited for handling highly complex tasks requiring intricate code, logic, or advanced algorithmic implementations. Tasks involving complex control flow, optimization, or specialized algorithms may exceed the capabilities of openinterpreter. Scope of use cases. The tool's limitations in handling complexity may restrict its applicability in certain advanced use cases, such as software development for complex systems, high-performance computing, or specialized domains requiring domain-specific knowledge and expertise. Accuracy. Reliance on natural language processing (NLP). Openinterpreter's accuracy is contingent upon the accuracy of its natural language processing abilities. While advancements in natural language processing have improved the tool's accuracy over time, there is still a risk of misinterpretation of incorrect execution of instructions, particularly in cases involving ambiguous or context-dependent commands. Error-prone interpretations. Natural language commands may be prone to misinterpretation due to ambiguities, colloquialisms, or linguistic nuances that openinterpreter may struggle to reconcile. Users must remain vigilant and review the generated code to ensure accuracy and correctness, particularly for critical or sensitive tasks. Overall, while openinterpreter offers significant advantages in terms of accessibility, ease of use, and efficiency, it is essential to acknowledge its limitations and potential challenges. By understanding these cons, users can make informed decisions about when and how to leverage openinterpreter effectively, balancing its benefits with its inherent constraints. Additionally, ongoing advancements in natural language processing and user feedback may help address some of these limitations over time. Overall, openinterpreter holds tremendous promise as a tool that can democratize programming, streamline workflows, and foster innovation across diverse domains. While it may not completely supplant traditional programming paradigms, it undoubtedly offers numerous benefits and opportunities for users. Accessibility and inclusivity. OpenInterpreter makes programming accessible to a wider audience, including beginners, non-technical users, and individuals from diverse backgrounds. By providing a natural language interface, it removes barriers to entry and empowers users to engage with computational capabilities more easily. Efficiency and productivity. With OpenInterpreter, users can streamline their workflows, automate repetitive tasks, and prototype ideas quickly. This leads to increased efficiency and productivity, enabling users to focus on problem solving and innovation rather than grappling with syntax and intricacies of traditional programming languages. Innovation and collaboration. OpenInterpreter fosters innovation and collaboration by providing a common platform for expressing and implementing ideas. It enables cross-disciplinary collaboration, facilitates knowledge sharing, and encourages experimentation, leading to novel solutions and insights across various domains. Education and learning. As an educational tool, OpenInterpreter helps learners develop computational thinking skills, problem-solving abilities, and programming proficiency. It provides a hands-on approach to learning programming concepts, making it engaging and accessible for students of all ages and backgrounds. Flexibility and adaptability. OpenInterpreter's flexibility allows it to be applied in diverse contexts, from software development to data analysis, research, and task automation. Its adaptability to different use cases and domains makes it a versatile tool that can address a wide range of computational needs. Continuous improvement. Through ongoing research, development, and user feedback, OpenInterpreter can continue to evolve and improve over time. Advancements in natural language processing, error handling, and performance optimization can further enhance the tool's capabilities and usability. In summary, OpenInterpreter represents a significant advancement in the realm of natural language programming, offering a promising approach to interact with computers more intuitively and efficiently. While it may not replace traditional programming entirely, its potential to enhance accessibility, efficiency, and collaboration makes it a valuable asset for users across various domains and skill levels. With continued refinement and adoption, OpenInterpreter can play a pivotal role in shaping the future of computing and programming.